Hey guys, so here we are going over the evens to finish off this review. So this should be by Wednesday or Thursday, and you should be doing your corrections and then uploading all your work, like your remember your rough draft, your corrections to the ones that you didn't do good on your rough draft, and then submitting all of that together. Please make sure you number the problems. Please make sure it's neat. Please don't treat it like a piece of scratch paper. Okay, I need to be able to see where it is. So to give you proper credit, I need to see your work. Okay, all right, so please follow those instructions. All right, so we're gonna start with number 2. And we are using the graphs to find the limit. That's just like the 11.1 notes and homework. So we're finding the limit as x approaches 2. So it looks like these are counting by 2's right here. So this would be 2 on the x. And it's coming up here somewhere. I think it's going to be at that open dot. So I think it's 12, but I'm not entirely sure. So I'm going to plug in a 2 for x. But remember, we couldn't do that at the beginning because we need to, if I plug in a 2, 2 minus 2 is 0, and it wipes it out. So that kind of tells me it is that point. So it is going to be 12. But remember, in 11.2, we learned how to tackle that. So we can factor this. We can factor out a 3, and we'll have x squared minus 4. And then x squared minus 4 factors down to x plus 2, x minus 2, with a 3 out front. And so then the x minus 2's will cancel, and we'll just have 3 times x plus 2, and now we can plug in a 2, and it'll work. 2 plus 2 is 4, 3 times 4 is 12. So it is 12, okay? This graph, it was kind of hard to see, but I could have even just been like, oh yeah, it's gotta be the 12, especially because the denominator was gonna go away once we plugged in a 2. So it is undefined at that point. Number 4 is the limit as x approaches 1 of 1 over x minus 1. Well, as x approaches 1 from the left and the right, we have this asymptote here at x equals 1. And it's going to infinity up above here, to negative infinity down below there. So it's going to infinity. So the limit does not exist. D and E. My kids are watching Three Ninjas. Have you guys seen that? It's an older movie from like the 90s, and it's really good. I grew up watching that movie. It's a little bit corny, but you will enjoy it, especially the guys. Like, I feel like you guys would really like it. My brothers love this movie, and I liked it too. I had a crush on the oldest boy, Rocky, just saying. But anyways, that was when I was a kid. So look it up. It's on Amazon. You can rent it for $3.99, Amazon Prime. Number 6, we're finding the limit as x approaches negative 1 of the sine of pi x over 2. So as x approaches negative 1 on the left and the right, we're over here. And that point is a y value of negative 1. So the limit is negative 1. Okay. And if we think about it, if I plugged in a negative 1 for x, I would basically get pi times negative 1 over 2, which is negative pi over 2. Negative pi over 2 on our unit circle would be down here. That's also negative 90 degrees. And the sine value there, it's 0, negative 1. So the sine, remember cosine would be 0, the sine would be negative 1. So thinking of the unit circle. Unit circle is a necessary thing for calculus, guys. Okay, number 8. We're finding the limit as x approaches pi over 2 of the secant of x. Pi over 2 is right here, and there is a vertical asymptote there. And it's going to infinity on the left and the right, so the limit does not exist. D and E. Okay. All right, I accidentally did number 10 in the last video, so we're on to 11. And it is the limit as x approaches negative 3 of 2x squared plus 4x plus 1. So I just have to plug in a negative 3 for x. So 2 times negative 3 squared plus 4 times negative 3 plus 1. Okay, negative 3 squared is 9. 9 times 2 is 18. 4 times negative 3 is negative 12 plus 1. 18 minus 12 is 6. 6 plus 1 is 7. So the limit is 7. Okay. Number 12. So we have the limit as x approaches -1 of the square root of x plus 2. So we just have to plug in a -1 for x. So it's the square root of -1 plus 2. -1 plus 2 is 1. The square root of 1 is 1. So the limit is 1. Okay, on to the next page. Those are pretty easy. At least I hope you guys think those are easy, because they really are. Oh yeah, I accidentally started on number 14, but I caught myself. So the limit as x approaches 6 of this. And when we're finding the limit here, if I plugged in a 6 right now, 6 squared minus 36 is 0, and then I can't do anything because we have a 0 in the denominator. So we have to simplify that fraction. So by simplifying, I'm going to have to factor x squared minus 36, and I can because it's a difference of two perfect squares. X plus 6, x minus 6. Okay, and then there we go. We get the x minus 6's to cancel. So all I have left is 1 over x plus 6. So now I could plug in the 6 for x, and I'll get 1 over 6 plus 6, which is 1/12. Number 16, we have the limit as z approaches 0 of the square root of 7 minus z minus the square root of 7 all over z. So whenever we have this, and we have to simplify it, because right now I can't plug in a 0, like the z would be, it's in the denominator, that's all there is, it would make the denominator 0. We have to reverse rationalize, so I have to multiply by the conjugate. And the conjugate would be the square root of 7 minus z plus the square root of 7. And whatever I do to the top, I got to do to the bottom. Okay. And we're going to multiply that out. So I'm going to get the limit as z approaches 0. In the denominator, remember to keep the junk in the trunk. I'm going to have z times the quantity 7 minus z plus the square root of 7. We just leave it just like that. And then square root of z minus, or 7 minus z times square root of 7 minus z. The 7 minus z gets to come out. Square root of 7 minus z times the square root of 7, positive. And then negative square root of 7 times square root of 7 minus z is the negative version, so those cancel. Negative square root of 7 times positive square root of 7 is a negative 7. 7 gets to come out. Radical times itself, the number gets to come out. These 7's cancel because they're exact opposites. And then if I were to rewrite this, pretend those 7's aren't there, the z's would cancel. But remember, this z is negative, so what will be left in the numerator is a -1. So these z's cancel. And so we have basically a -1 over the square root of 7 minus z plus the square root of 7. And now we could plug in the 0 for z. Well, 7 minus 0 is still 7. So I have a square root of 7 plus another square root of 7. So now I have 2 square roots of 7. So -1 over 2 square root of 7, and you can leave it like that. Okay, number 17. We have the limit, oh wait, I already did it. What am I talking about? Number 18. So if you guys remember, you had a problem similar to this in the first set of notes. And it was like the numbers 25 through something or other in 11.1. So for these ones, remember it said to graph and see what happens. So what we can do is we can graph it by hand, or we could go on Desmos. So because you have your resources right here right now, I'm going to go to Desmos. So let me turn on, my computer was sleeping. Okay. And, okay. Oh, I even have it up right here because I was looking at it earlier. Okay. So here it is. I already have it pulled up. I have y equals 4 minus x squared and y equals 3 minus x. I have the two functions on the graph. But remember, it said for the parabola, x has to be less than or equal to 1. So these are counting by 2's, 2, 4, 6, 8. So from 0 to 2, halfway in the middle would be where 1 is. So on the parabola, 1 is right where my cursor is. And it said that x has to be less than or equal to 1. So from that point to the left, okay? All right, for the blue graph, the line, it said that x has to be greater than 1. So on the line, x has to be not on there at that point at all. It has to be bigger than 1. So from that 1 over, so not including the 1, but over from it to the right. Well, if the parabola can be, if the point can be on 1 at the parabola, but to the left, and on the line past 1 on the right, they're not going to be in the same spot at the same time. So guess what? What does that mean? The limit does not exist. But the only way that you would know that is to graph it. And you can graph it by hand because this is just a parabola. I mean, if I would flip this around, I would have in standard form negative x squared plus 4. So the negative means the parabola is facing down. So you just take the parent function, flip it down, and shift it up 4 units. So it's up at 0, 4 on the y, facing down. And then this is a line. The slope is a -1. The y-intercept is a 3. You know, y equals mx plus b. And then you would graph that. Like, they're easy to graph. But you can use Desmos, okay? You won't even need to use Desmos on the test, okay? All right, that was 18. We did 19 in the last video, so we need to do 20. And was 20 long for me? No, I could do it right here. I think I'll have enough room. I might zoom in a little bit because I want to write small. So we have g of x equals x cubed, and we are finding the slope at the specified point. So we're finding the derivative, and then we're plugging in the x value. We don't need the y value to figure out what the slope would be at that specific point. So that means we have to do the f of x plus h minus f of x all over h thing. So we have the limit as h approaches 0 of, I need to plug in x plus h, so x plus h quantity cubed minus g of x, which is just the x cubed, all over h. Okay. All right, so to expand the x plus h quantity cubed, instead of multiplying out x plus h times x plus h times x plus h, which you could do, it takes some time though, I'm going to use Pascal's triangle. And I need to go to the row where I see the 3's, because that means we're to the 3rd power, okay? So the coefficients, it's going to have 4 terms, and the coefficients are going to be 1, 3, 3, 1, okay? So I'm going to simplify that out. We have the limit as h approaches 0. I know it's all over h. And I'm going to have x to the 3rd, 1x to the 3rd, plus 3. Now the x degree goes down 1, but now the h degree goes up 1. Plus the 3rd term coefficient is a 3. X degree goes down 1, h degree goes up 1. And then plus the last number is a 1, and the x degree goes down 1, so it's just x to the 0, which is just 1. And then the h goes up 1. And don't forget, we have minus x cubed there. We'll squeeze it on at the end. Okay? All right, now we can get a little cancel happy. And the x cubed and negative x cubed cancel. And that's all that cancels. So pretend those are gone, because they are. And now we can divide out an h from everything. So if we have to take it from everything, though. So take out an h, reduce an h to 1, reduce the h to 2. So now we have the limit. Now I'll zoom out a little bit. The limit as h approaches 0 of, let's see, I have 3x squared left, plus a 3xh left, plus an h squared left, and nothing left in the denominator. But now we could plug in the 0 for that h and the 0 for that h. Well, 0 times anything is 0, so those get wiped out. So all I have left is 3x squared, okay? And now we could plug in the 1 at that, because that's at that specified point, so plug in 1 for x. 3 times 1 squared is just 3. So the slope is 3. Okay. Now we're finding the derivative, which is also a fancy way to find the slope. The only thing is that we're not given a specified point. So it would be like the 3x squared. We would stop there because we have nothing to plug in for x. Okay. So we did 21 and we did 23. So we need to do 22, and I believe I have enough room to do it right here. So I will. And it's still the whole f of x plus h minus f of x all over h type thing. So I need to plug in an x plus h there. So I have the limit as h approaches 0 of 2 times x plus h quantity squared minus 1. And now we have to subtract the g of x function. So I have to subtract the quantity 2x squared minus 1 all over h. Okay. And let's not forget, when we multiply out x plus h times x plus h, we get x squared plus 2xh plus h squared. But we have a 2 out front, so we're going to have to distribute that 2 as well. So this becomes the limit as h approaches 0 of, I'm going to have 2x squared, 2 times 2xh is 4xh, 2 times h squared is 2h squared. And then I have that minus 1. And then distributing this negative, I'll have a negative 2x squared and a positive 1, because a negative times negative is positive. And this was all over h. And now we can get a little cancel happy. The 2x squareds cancel, and the 1's cancel, negative 1 and positive 1. So 4xh, 2h squared over h is all I have left. So we can divide out an h from everything. And so we'll have the limit as h approaches 0 of 4x plus 2h, and there's no more denominator. We plug in the 0 for h, and that wipes out the 2h there, so all we have left is 4x. So that is the derivative. Okay, and that was 22, so now we're on 24 and 26, and then we're done. All right, number 24, we're finding the limit as x approaches infinity of 4x over 2x minus 3. Because we're approaching infinity, we're looking at the end behavior, remember, in the video. And so that means we're looking at the degree of the numerator versus the degree of the denominator. So the degree of the numerator is a 1, and so is the denominator. So their degrees are the same. When the degrees are the same, you look at the leading coefficients. It's a 4 over 2. Well, so the limit is 4 over 2, but 4 over 2 is 2. So the limit is 2. That was 24. For 26, the limit as x approaches infinity of x squared over 2x plus 3. The degree of the numerator is a 2. The degree of the denominator is a 1. So we have a big top. So that's the same as Buzz Lightyear. He's top heavy, and he goes to infinity and beyond. So that means that the limit does not exist, D-N-E. And that's it, guys. All right, so remember, your test is on Friday. It'll be from 9 to, what did I say? I think I said to 1, but I want to verify that before oh no, it's from 9 a.m. to 10 a.m. Yeah, we're only giving you guys an hour window to do that, so please make sure that you plan accordingly. It needs to be done in that time slot. So please, please, please make sure that you plan for that, okay? And I am going to give you guys some good news, so hopefully you're listening to this. But the final is optional. If you need to take the final because you need to get a grade boost, because really there's no extra credit that I'm offering. The grade boost is passing assessments, and the final is worth 15% of your grade. So I'm leaving the final optional. So you don't have to do it, but if you want to work for a grade boost, it'll help, okay? So I'll leave that up to you guys, but, you know, it's just throwing it out there that it will help your grade if you're looking for a way to jump up, okay? If it shouldn't jump you down unless you totally bomb it, but, I mean, at this point, you guys are, a lot of you guys are moving on to calculus, so you should be doing pretty good. All right, but it is optional, so it will be up to you, all right? And you still have to do the review, though. But anyways, so I will leave it at that, and have a good one, you guys, and I'll see you in my next video. There's not many more left. Bye.